So let's review a little, and I was looking at your end of module assessment for module 1, just to kind of get some review questions, and I ran across something like this that I don't remember ever seeing in module 1, so we're going to go over it. That's a little too big. That's still too big. What's going on with this thing? Raise your hand if you can tell me what order of operations is. Number 14, pay attention, please. Tell me what order of operations, yeah. Okay, that's place value. Has anyone heard of order of operations?
Pretty sure that it's taking all these numbers and once you multiply them, you're not actually multiplying, but actually adding them on the place value there.
Okay, what do you think?
I think that's like, if you have an answer on your place value chart, and you can write it.
Okay, maybe write standard form. For some reason, I just don't remember seeing any of this in Module 1. Maybe it escaped my memory, but we do order of operations. Go something like this. Please excuse my dear Aunt Sally. What do you think each of those represent? Okay, so it's an acronym maybe for a process that you need to use in math. So what do you think the P means? No. Nope. Nope. Think about something we've been using this year that you haven't probably used in the past. Nope. Okay, I write down the definitions. What is that one thing you do when you break the number down? What's that property called? Do you remember? Distributive. And what do you usually use in the distributive property? Parentheses. So you guys might want to write this on your paper so you don't forget it. Then what do? What do you think that E is? Estimate? What do you think? Exponents. Yeah, it's these little numbers here, you know, the little exponents, 2 and 3. So it's one of these exponents. Then what do you think the M means? What do you do then? Are you guys writing this down on your paper? You might want to. Then what do? Multiply. And number 3, do you know what to do on D? Divide. 6, what do you think? What's okay? A stands for add. And everybody, what's S mean?
Subtract.
So let's look at this one. Actually, is going to be our easier one. I mean, you've talked about 1/10, 1/100, and that kind of thing, but you really don't know what to do with those. So, do I have parentheses in that problem? Do I have parentheses in that bottom problem? Nope. So what's the next step that we need to do? So I'm going to put a little check mark here because I know that that's done. What's the next thing I need to do? See if there's exponents. Do I have exponents in this problem? Okay, so what's 10 to the power of 2? 100. And what's 10 to the power of 3? 1,000. Then you just add these numbers back onto it. Let me change colors here. Okay, so we did the exponents, so now what do we do? Now what do we do? Multiply. So I have these two that I can multiply together, right? And I have those two I can multiply together. Well, if you remember on your place value chart, when you multiply by a power of 10, you're moving the decimal to the, anyone remember what direction you're moving? To the right. So you're moving a decimal to the right, however many places we go as far as the zeros. So I have decimal 3 times 100. So what's going to happen with my decimal? Or I have 3/10, I guess I should say. It's going to move 2 places to the right. So when I'm done, I take my decimal, move it 2 places to the right. What's 3/10 times 100? 3/10 times 100 is 30. What am I going to do with this number? Seven thousandths times 1,000. What am I going to do with it? So I'm going to move the decimal 3 times to the right. 1, 2, 3. So 7 thousandths times 1,000 equals 7. So what's 30 plus 7? 37. You know what I like about this math? If I would have pulled a problem out like that last year on my students and the past 16 years on my students, I would have heard, but you guys just already know every day is going to be a challenge, so that's good. Because now you have open minds. That was actually pretty easy, wasn't it? Yeah. I mean, I think it was pretty easy. This next one's going to be really easy too, but there's a difference in this one. Okay, we have a place value chart, and every time we go one place over to the right, what do you notice about our numbers? What do you notice about this? As it goes this way, what's it doing? First we start with a dime, then we start with a pen, then we go to a penny, then we go to who knows what. A peso, maybe, I don't know. Huh? It's getting smaller as we go along, right? But if I have this number, 31, and if I have 10 to the power of 1, would my number get bigger? Would it get bigger? If I had it like this, 31 times 10 to the power of 1, would it get bigger? It would get bigger, right? Yes. What would it become?
310.
Yeah, because remember, you're moving, when you go times 10, you're going to move it one place over. Do you remember that, how we did that with the arrows? What do you think's going to happen if we do like 1/10? If we take that and do 1/10? Well, fraction is like a division problem, and division's opposite of multiplication. So when we multiply, if we move these numbers one place over to the left, what do you think we're going to do when we do the division or the fraction? You're going to move it to the right. So let's look at our order of operations. Parentheses. Do we have parentheses in this problem? Nope. Do we have exponents? Do we have multiplication? And in order of operations, you do whichever comes first, multiply, divide. So on 31 times 1/10, what do you think I'm going to do with that number? What's going to happen? If I moved it to the left one place when I multiplied by 10 to the power of 1, what am I going to do with it this time? If I do it times 1/10. 18, 19, whatever you are, pay attention. What am I going to do? You guys just told me a minute ago. Going to move the number to the right. How many places? How many zeros do I have? I have 1 0, so I'm going one place to the right. So this number would become 3 1/10. Now look at that a minute. This equals tell me what a good strategy you can use to remember this. What happened to my decimal? Did it go to the right? I started with 31, and now I have 3 1/10. So what happened to my decimal? It moved to the left. So when you have a problem like this, I just did all that just to give you a visual. Let me delete this now. We don't need that. Whoop, hello. Let me take that back. So we have a number like this. How many places to the left are you moving the decimal? 1 time. If you have a number like this, how many times to the left are you moving the decimal? 2 times. If I have a number like this, how many times to the left am I moving my decimal? Everybody?
3 times.
3 times. I think we'll have time for some review today, so when we do some review, we'll click in just practicing how these numbers would look. So we do multiplying now. What's this number going to become? Okay, 3 1/10. And anyone? What's that number going to become? 18?
That's gonna become,
No, let's think about it. We have the imaginary decimal here, right? How many times to the left are we going to move it?
2 times.
2 times. So what's it going to become? It's not going to be 1 4/10. It's going to be what? 14.
And
What's the second place in the?
100.
There you go, 1400. Does that make sense, people? And now you have to move the rest of your numbers down. So we have 2. Whoops. And I'm trying to add that 14 back again. Can't do that. There. Can we solve this problem now? I hope I have the answer.
How many times do you now have the light?
Just based on zeros. Because if you think about it, 10 times 10 is, what's 10 times 10? Equals 100. That would also be 10 to the power of 2. So I know to move it how many places? What's it tell me? 10 to the power of 2. I move it how many places to the right? 2 times. Good question. And then when you add and subtract, this is also based on whichever order happens first. So if I had subtraction first, I would subtract first. If I had addition first, I would add first. So 2 plus 3 1/10. Anyone know?
5 and 1/10.
Okay, 5 1/10 plus 1400 equals, anyone have the answer? What do you think?
5.15.
Is it 5.15 or
5
5 and 1500? There you go. Okay, we'll review a little bit more of that in a little while after I go over today's lesson. Yes, ma'am.
I thought 5 was 2400 because.
Oh, 5 and 2400s? What was our original number? Oh, yeah, it is. It's 24. Yeah. Because you have to add them, yeah. Sorry. There you go. So my cyber people, I apologize. That's what happened. See, I started talking about today's lesson, and then I wasn't even thinking. Gotta get my brain on the right page here. Today is really nice because it's like a review of what we've already been talking about. It says on lesson 7, problem set 1, then draw an area model, and then solve using the standard algorithm. Now, a lot of you have See Me on your lesson 5. If you have that, you need to pay extra close attention, because we're going to do the standard algorithm first. This is number 1A. Because everybody who needs to see me about lesson 5, this is what you forgot to do. This is what you forgot. So we start in the ones place. So where's our first number going to begin? You start in the ones place, your first number starts in the ones place. So it's going to start right here, in the ones, right here. So 2 times 1 is 2, and that starts in the ones place. 8 times 2, everybody? 16, carry the 1. 4 times 2? 8 plus 1 is 9. Now I go to my second number. If you want, you can just cross this out. Now I go to my second number. Where does the second number begin? Why did you put the 0? That's right. My second number begins in the tens place. So that means my answer is going to begin in the tens place too. So I'm going to just put a 0 there to mark my space. Okay, everybody, 5 times 1? 5 times 8? 40. Carry the 4. 5 times 4 is? 20 plus 4 equals? Now, if you kind of have a hard time keeping your numbers lined up, you may want to use graph paper for this and write your numbers in those boxes, because I know some of you are adding incorrectly because you're trying to squeeze them all together, and then who knows what you're adding. It's not triangulation, it's, just regular straight up and down. So I'm on my third number now. I've already done my first 2. So where is that going to start? That's right. Do you notice when you look straight down? Look, when I look straight down from the first number, my answer begins right below it. When I look down from this number, straight down, my answer begins below that. And when I go straight down from this one, my answer is going to begin right there. So 3 times 1? 3 times 8? 24, carry the 2. 3 times 4? 12, that'll 14. Plus 2 is 14. 2 plus nothing? 6 plus 5? 11. 9 plus 1 is 10, plus 3 is? 13. 4 plus 4? 8. Plus 1? 4 plus 2? 6. And then 1. So now you shouldn't have gotten any of these wrong, though, if you did the area model with it. And the people who had a hard time with this, the issue was they didn't have an area model because it just said do the standard algorithm. Don't forget, every 3, 1, 2, 3, put a comma. You start this side right here and go to the left. You don't start at the right. Who can do a area model on this for me? Maybe I should draw a stick. I think I'll draw a stick. I think that's what I'll do. I'm going to just write this number over here to remind myself of what the answer was.
We're going to start out with 3 for 352. Then 50. And then 1
2, and then 4. I can't draw this. I can't draw with this thing. 100, and then
You gotta own it. Why don't you tell me what to write? Is that right?
no, that's 80.
50, right?
Yes. That's 80. And then this is 2. No, I mean 1. And then you're gonna add 3. You're gonna times 300 times 400. That's 12,000. 4 zeros. So that would be 3,000. And then going to do 80 times 50, which is 40. And then you're going to add the 2 zeros. And then 1 times 2 is 2, and you're going to do that lot. And then 350 times 400 is 20, and then you're going to add the 3 zeros. And then 400 times 2 is 8, and then add the 2 zeros. And then 80 times 300 is 24, and then add the 3 zeros. And then 300 times 1 would be 3, and then add the 2 zeros. And then 1 times 50 would be 50, and then 80 times 2 is 16, and then add the 0. And then you're going to add these up. 0, 0, 8, 0, 4, 1. And then 28 and 160. Answer for these. 0, 6, 1, 8, 2. And then this would be 352. And then we add these up. Two, 11, carry the 1. 13, carry the 1. 9, 6, 1.
Is it the same answer?
Yes.
Most likely, if you got the same answer twice, that your answer is probably right. Unless you're multiplying and saying the wrong answer, like if you did 8 times 5 and said it was like 35 or something, that would mess up your answer completely. So that's the first problem set, A. On B, I'm going to have you click on the answer. And so when I come around, the first thing I want to see is that you're doing an area model on your desk first or in your book. So I'll be looking for an area model, and then I'll be looking for the standard algorithm before you submit your answer. You can go ahead and get started on your homework while people are still solving the problem. Homework is going to be all 5 problems. When we solved the first problem, yep, we're going to do the word problem too. I was going to go over it with you real fast here. It says on problem set 1C that both 1A and 1B have 3-digit multipliers. Why are there 3 partial products in 1A? Remember how we had the 3? Okay, remember in this one, the first one, we had 3 partial products. This is a partial product. This is partial product. That's a partial product. We have 3. But it said in the second one that there's only 2. Why would there only be 2 partial products where you multiply 481 times 302? Okay, good. So actually the 0, you don't have to worry about the 0. I think that's what's making some of you kind of slow down on this. So the answer to C would be that B word problem, I'll go over the one with you before we start reading groups today. The rest of it you should know how to do pretty easily, I would say, hopefully by now. Once you have that copy down, you need to go ahead and get ready for MTSS. We're not going to the computer lab afterwards today. You're going to be starting, I have a meeting, so you're going to be starting social studies right after lunch. So once you're cleaned up, you can go ahead and go to your